I'm Richard, and a friend of mine was just talking about a concept of situational code bases, which is code that only works in one environment, or is only ever intended to work in one environment, and it generally co-evolves with its environment. And that reminded me of an example I had lying around, which is I have over here a stack of computer programs that only work on one, each only works on one fictional spaceship in one video game called Space Engineers. I'm just going to show you one of them in action here. This one is called CakeSpiral, and it's tied to the design of this specific spaceship. The spaceship is called CakeFoot because it's kind of, I don't know, the name kind of reminded me of cake. The colours kind of reminded me of cake, and there's a foot on it. Yay, feet. So what I'm going to do with this is fly it up to this chunk of rock very, very slowly. You'll just see that foot go yellow in a second when it touches. Okay, that is now landed. I'll switch the drills on for reasons and activate this program. And this program is going to spin the whole ship around once by using this rotor that's on the end of this piston. So this is a rotor here, and it's got a piston on the end of it, and there's a landing gear on the end of the piston. The landing gear acts like a big magnetic foot, or it just clamps the spaceship onto whatever I attach to the other end of it. What this is going to do is, like I say, turn the drills on and spin the drills around once, and then once they've made one 360 degree rotation, which you can actually see here, it will grind around in a spiral. So the programmable block in this script is watching the rotation angle of that rotor there, and every time it makes a full turn, it is moving this piston inwards by, I think I've got it set to 0.8 meters. Where's that programmable block? Yes, that's 0.8 meters. And it's just lazily and slowly spinning around, going down a tiny piece at a time. You can see it very slowly cutting into the rock here. The reason this program exists in the first place is because if this thing tries to go down too fast, it ends up hitting the rock a lot. But if it doesn't go down fast enough, I'm going to end up wasting time waiting for it to go around and round and round and round and round. I could have just set the piston to a constant velocity, but that then becomes a really difficult tuning problem. So we make the piston move according to how well the rotor is doing. And that keeps everything nice and, what's the word I'm looking for? Nice and proportional. Let's see. Ooh, it does wobble a bit, well, but it's pretty harmless. I'm just going to use the remote control and show you some of this program. So, big old comment at the top explaining what it is, how you configure it, what commands it will accept. There's a bunch of Space Engineers specific stuff where it has to serialize be able to serialize the program state to a string, stuff that into a string variable called storage at any point. and also at any point be able to load that back from the string storage variable. This is so that it can support save games, because they can't serialize arbitrary programs written by strange, unknown people such as me. Let's see, and this is here's the entry point. Does various things about setting up printing to standard out, where standard out here is actually where is it called? There's actually a block in-game which is an LCD panel, and when something in that script calls printer.print string, it's going to actually get dumped into that panel there. If I were to set verbose true, it will print what's... It's a bit of a weird result. If I were to set verbose true in here and then hit the load command, it will print what it's doing as it goes, hopefully, unless I've made some kind of really embarrassing bug. Ah, there you go. Now 6 times a second it's adding a line to this. This will get really full really fast. But you can see it's counting up how much rotation it's accumulated, and the piston is moving down proportionally. I'm just going to turn verbosity off and then reload, and it'll stop doing that. As you can see that this piston has now retracted a lot from where it started, and as a result this thing has dug out a big circular flat area. Mm. 0.8 meters was probably a bit optimistic for this, as was the 3 revolutions per minute. Nah, but whatever. Those are both constants that can be changed. Not constants, variables that can be changed in the configuration of that script. In another minute or so it's probably going to finish. In fact, it's very nearly finished. If I look at this, it might say something about switching state. Yes, there it goes. So it switched state from the spiral grinding state to the rotate again state, which is the last one before it stops. Once the piston has reached the bottom and the drills have reached the end of their linear range, it'll just rotate around one more time to make sure that the bottom layer is fully cut up. And then it will switch. It's just decided it's finished, switched off the rotor, and switched off all the drills. Whee! Hang on. Oh, it's on the other side. Helpfully gone and put the LCD facing into the sun, so this game has accurately simulated the fact that reading an LCD in sunlight is really annoying and difficult. And as a result of this, there is now a huge quantity of nickel ore inside this ship. Sweet.